Okay, guys, so we got a quick little thing for you here. As you get into this Explore It Oceans Currents, at the very top it says click the link here for the map. So what I want you to do is click that hyperlink and it will open up this map that you're going to see right here. I want you to use this map to answer the questions below. Now, what we're going to look at is we're going to look at this idea of a map with a bunch of arrows on it. And so you're going to be asked a couple of things, but what is this map actually showing us, Mr. Jensen? What is this thing about? Well, as you can see, there's blue lines all the way through the ocean, and these blue lines are what are showing you ocean currents. And there's actually names for these: North Equatorial Current, there's Equatorial Countercurrent, there's the South Equatorial Current, the Gulf Stream Current, all these different currents, the California Current, the Alaskan Current. You can see there's a ton of different currents listed. That's because the ocean is always, believe it or not, it's always moving. And so these currents, they go throughout our oceans. Now, what we're going to do is we're just going to look at this a little bit together and just learn a little bit about this ocean currents. Weirdly enough, there was a time where a ship was making its way from China. It was full of tennis shoes, Nikes, and all sorts of stuff. And randomly, as people were walking down the beach of California, kind of Northern California, all these tennis shoes washed up. And they're going, where the heck are these tennis shoes coming? You got all these new Nikes washing up on shore. Well, this cargo had actually lost a bunch of tennis shoes, and those tennis shoes floated and rode the current and ended up all the way through this current into California, which is crazy to think about, that something could travel that far. And so these currents that we're talking about are throughout our oceans, and these are the ocean currents. So what does this represent? This represents water flowing. Now you might be wondering, what the heck are these currents? This is on the surface of the ocean. So the thing that causes these currents. So Mr. Jensen, what makes these currents? Might be your question. What makes these currents? Well, the big answer is wind is driving these currents. And what's wind caused by? Wind is caused by the sun. So wind is from a high pressure to a low pressure caused by the sun. So what's really causing all this to happen? The sun is the main cause of it. Without the sun, you're not going to have any of these currents. But it's causing the wind, and the wind is pushing across the surface of this and causing these currents, which is kind of cool, actually, I think. In fact, if we were to look at a view of this thing, let me show you what this looks like. I'm going to drag this right down here for you to see for a second. But here are some views of an animation showing these currents throughout our ocean. Now you could see, here's the United States right up in this area here. And the United States, this is the East Coast. So New York's here, Florida's down here. But here's a Gulf Stream current making its way up along our coast. And there's a lot of water moving very fast across this area. And it goes all the way up into the northern areas. Now, when it gets to the poles up here, what ends up happening is it cools down and it sinks down. And so the surface current actually dives deep within the ocean and goes to the bottom, and it makes its way back to the equator. And it picks up some more currents that are coming from the North Pole. So there's these deep trenches that these currents come down through. But what we see is we see these surface currents. This is the one that we're talking about right off the coast, the east coast of America. These surface currents dip down in a certain area, and they make their way back towards the warm equator. But this is what's happening with our ocean currents. If you were stuck in sea, if you're stuck in the ocean, you would have ocean currents drifting you at a drift. It wouldn't just be the wind, it would be the ocean currents caused by wind that would be drifting you through. And so here it is, ocean currents as you can see them. And it comes all the way down. In fact, you could see deep ocean currents, which we're going to see in a lab coming up here. We're going to see deep ocean currents coming all the way through as well. In fact, we call this the ocean conveyor belt. And you're thinking, what the heck? Well, when you go to the grocery store, you put your groceries on what's called a conveyor belt. It moves your groceries towards the person that's going to check you out and take your money and whatnot. This is the conveyor belt that moves throughout the entire world. It's called the ocean conveyor belt, and it's currents that are moving surface-wise and deep. Now, it's different. The reason why there's a deep current, that's dealing with density, and we're going to see that in a lab. But the ones that we're seeing up here are what we call our surface currents. So these currents are all at the surface. Now, caused by winds, of course. I'm saying that again. So what do the arrows represent, Mr. Jensen? The arrow just represents this direction. The arrows are representing the direction that the currents are going. What do you think causes the oceans to flow like this? Why do the oceans look like this? Why are they circling through? Look at this. This arrow shows that it actually moves this way. And then it comes back through again in a circle right here. And check this out. This arrow points here, and then it moves a little further down here, and then it comes back up in here, and it moves up here. This is circulating throughout the whole thing, Mr. Jensen. This is kind of weird. I'm not really sure. In fact, weirdly enough, there's a counter current going this way and then a current going this way. What causes this? Well, what causes this current is a big thing called wind. Wind is the cause of this. That's what's causing all this to happen. It's the wind. Wind is constantly moving over the surface, creating these surface currents. Wind is what causes this. So we've got these ocean currents caused by wind. Okay. What about this, though? What about the temperatures of the waters as they flow towards the equator and away from the poles? What happens there? Well, if you remember clear back from when we talked about seasons and everything else with space and things, the equatorial regions are these middle regions here. And they get the most sunlight. Most sunlight. So their temperatures are warm. It's where we have all of our tropical forests, things like that. At the top, though, here, this is where we have the least sunlight, being that it's down in our polar regions in the south and the north. And so down here and up here, it's going to be cold. And down here, it's cold. We have cold. Well, with that cold area and that warm area, this is going to affect the ocean temperature as well. So at our mid latitudes here, or the equator, it's going to be relatively warm. And so what you're going to see is this. From this cold Alaskan current up here, it's cold, so the water is not going to be very warm. This is our west coast. So I'm going to write the word west. And as you can see, the arrows are pointing down here. So what would it be like to swim in California? On the west coast. What do you think it would feel like? Where's that water coming from? Where's that water coming from? Well, it's coming from up here in the Alaskan area. So guess what? You're going to be cold when you swim in that water. It's true. If you go to Oregon, Seattle, California, the water's cold. It's not very warm. Yes, it is. Then you have a different version of temperature than I do. So, most people. But yeah, California tends to be a lot cooler because it has that cold. What about down in here? Down here, look at these arrows pointing up through here. Remember, we're coming up through here, and this is warm down here. It's warm. And so this is what we call our east coast. East coast. And so you've got water coming up through this area. Well, what's it going to be like if you were to swim on the East Coast? What would it feel like? Big thing. It's going to feel pretty warm. You've got all of that water moving up from the tropics, so it's going to be warm. So you're going to have a nice swimming. In fact, in New York, I mean, they swim up here in New York, which is up in this area here. They're swimming in the oceans. Yeah, there's a warmer water up there due to these ocean currents, where they're coming from. Interesting. Well, we've got these areas where there's circles, and there's one right here where it goes in a circle. There's one right here, goes in a circle. There's one right here. There's one up here, and there's one right in here. The Indian Ocean. So we've got the Pacific as one, Indian Ocean, South Pacific, North Atlantic, South Atlantic. These are the 5, and we have a word for these, and the word is gyres. Gyres. Oh, I forgot to put an E on it. Darn it. I just realized I forgot an E. 5 gyres. A spinning motion like this is called a gyre. There's 5 main gyres. There's one in the North Pacific, South Pacific, North Atlantic, South Atlantic, and here in the Indian Ocean. 5 main gyres. There you go. This is the surface currents moving through our oceans. So if you get lost at sea here, you can pretty much guarantee you're going to be slowly moving your way this way. If you're down in here, you're going to be moving your way in this way. Don't get trapped here. You're going to move your way all the way up there. This is how it works with ocean currents.